So if you have doubts in week 9 to 11, that will be cleared out here mostly. Is it visible to you?
Yes.
Yes, ma'am.
Okay. So in this paper, we have quite a few questions from graph theory, which make up almost 25 to 30% of the paper is based on graph theory questions. Okay. All right, let's start. The first question for 5 marks. Consider the procedure do something as shown below. So procedure do something takes two arguments, x and n. If n is exactly equal to 0, then we directly return 1. Else, if n is anything other than 0, then you come to else part. And what do we return? X into do something x comma n minus 1. So what does this procedure do when I pass 3 and 2 as arguments? So you can directly dry run it here, right? So let's do something for 3 comma 2. So first, let's check for first call. So since this is a recursive type of problem, right? The function is calling itself. So there's recursion. So we'll say that this is the base call. And the first n is what? 2. This is my x, this is my n. So if n is equal to 0, this statement is invalid, n is 2. So come to the else part. And what will this return? 3 into do something of 3 comma 1. Right? N minus 1. X remains same. Now we directly move to this call. So this is the second call. Again, you check, is n equal to 0? No.
No, ma'am.
Come to else part, return statement will be 3 into do something of 3 comma 0. This is the third recursive call. Basically the second recursive call, third implementation overall of this do something procedure. So now again check, this is x, this is n. N is 0 at this point. So we will return what? Return 1 from this line. So this 1 will be returned back to the last call. That is here. So this becomes 3 into 1. That is 3. This 3 is returned back to the call before it. This one. So 3 cross 3, this is 9. So answer should be 9. This is the coming back to the base call. So option B is the correct answer. Please mute yourself if you don't have a question. Okay. Is this question clear for everyone?
Yes, ma'am.
Yes, ma'am.
So this is pretty simple. Let's go to question 2. So consider the following procedure where L1 and L2 are two non-empty lists. So non-empty lists, that's all we know. Procedure compared lists takes these two lists as its parameters, L1 and L2. So if length of L1 is not equal to length of L2, that is if they have different number of elements, then directly return false. But if that is not the case, that means if they have equal number of elements, only then you will be able to come to line 5, right? Otherwise the function will stop here only. So while length of L1 is greater than 0, that means as long as it is non-empty, as long as list 1 is non-empty, what do you do inside the while loop? First if statement check that is last of L1 not equal to last of L2. That is, it checks the last element from each of the lists. If they are unequal, then you directly return false here. That means if they're equal, only then I can come to line 9. Okay. So if they're equal, if last of each of the last elements are equal, then you come to line 9 and L1 is now init of L1. That means which element is removed?
Last element.
So last element is removed from both lists. When is this happening? When both lists have equal last elements. So L1 and L2 are now both containing init of L1, init of L2, right? So like this, the while loop will continue how many times? See, look at the conditions here. First, we will come to the while loop only if L1 and L2 have same number of elements. Now while loop will run how many times? As many elements as there are in each of the lists, right? So here this condition, you can check length of L1 greater than 0 or length of L2 greater than 0, since both have same length. Now for every iteration of the while loop, we are checking the last elements of the list, and if they're equal, then we are removing that element from both the lists, right? And reassigning to L1 and L2. If at any point I see that the last elements are unequal, then I can directly come out of the while loop and return false. So if all elements are equal, in that case, the while loop will execute until list 1 becomes empty, because at the same time, list 1, list 2 both will become empty, right? So now they're asking that choose the correct option here. So option A is saying if L1 is 235, L2 is 245, then compare list L1, L2 returns true. So will it return true?
No.
No, ma'am.
Because this 3 and 4 are not going to match, right? First, last elements 5, 5 are equal. So then these two will be removed. Now L1 is 2, 3, L2 is 2, 4. So now last elements 3 and 4 are unequal. So at this line, the false statement will be returned. So option A is not true. Second is saying 2, 4, 5, 5, 4, 2. This will return true. There is no chance of this returning true, right? Because none of the elements match. This is again false. Option C is 2, 4, 5, 2, 5, 4. Same way, it will not return true because of this 4 and 5 and also 5 and 4. In the first iteration only, it will return false because last elements don't match. So remaining is option D, 2, 4, 5, 2, 4, 5, exactly equal lists. This is the only condition when this procedure will return true, when all elements are equal at every index. So option D is correct. This is clear for everyone? Any doubt? Okay. Okay, let's see this. So following pseudocode is executed using scores dataset. At the end of execution, city D of K represents the dictionary with gender as key mapped to the lowest physics mark scored by that gender in city K. Means what? K is nothing but the city name, right? So what can I say about the keys of this dictionary?
So are cities.
Cities. So that means, can I say that city D is a nested dictionary, right? Because for every city, we have the what is the corresponding value part for every city? Another dictionary in which represents the dictionary with gender as key mapped to the lowest physics mark scored by that gender in city K. That means there will be two keys like this for male and female, and the lowest physics marks for each of the genders in city K are going to be mapped like this. So this is one entry in the city D dictionary, right? So we have to choose the correct code fragment to complete. So let's see. City D is an empty dictionary initially. Now we will populate it. So while table 1 has more rows, now you go through each of the cards in scores dataset, read the card. If now you check that is this like it's the town city in your current card is already a key of this dictionary or not. If it is a key, then obviously you don't need to insert it again. Keys have to be unique. So if is key, if it is already a key, then this part of the if statement will return what? True or false? If the current city in my current card is already a key of city D dictionary, in that case, is key will return true or false?
True.
True, right? If it returns true, then I can go into the nested if. Now here some statement is missing that we have to find out. So for some statement here, we are checking if city D X town city gender is greater than X dot physics. That means for this particular city, that means we now know that the city already exists as a key, right? We don't have to create the key for this particular city. So it already exists. So now what is left to do is we have to check that the marks that are already present for whichever gender for that city, we have to compare the marks with the current card. So whatever that gender is, right, for that card, we are checking that city D, X town city, X dot gender is greater than X dot physics. So do you understand what is this part doing?
Ma'am, can you explain again the one with the if condition?
The outer if?
No, ma'am. That if which you're like saying if condition. The
Yeah,
one with
this
this
one is the
gender.
missing statement, right? This we have to find out what will be put here.
Okay,
Okay.
ma'am. Below that, no, you just explain.
Yeah, this if. So this if is doing what? So see, think of it logically that now I know that for a particular city, there is already an entry in city D. That means I don't have to create a new key. Correct? Look at the brackets
Yes,
also.
yes, ma'am.
This outer if is closing where? This if
Okay.
closes here. This if closes here.
Um,
Okay. The
yes,
outer
ma'am.
if closes. This if closes
Um,
here.
okay.
Okay. So for this line 4 if, the corresponding else statement is at line 14. This else statement is for this if.
Yes, ma'am.
Okay. That means I am now checking that for my current card. Okay, let's take a card for example. Let's say this is the current card that I have, the X card, and this is for some girl. Let's say gender is female, and the physics marks is let's say 65. Fine. This is my current card information. Now, there is
Yes, ma'am.
some statement in this if which is missing. If this statement was invalid, then I will come to this else, right? So then only I can come to this else. That means in the else, what am I doing? CTD, X town city, gender, you are assigning the physics marks. That means for this gender,
Hmm.
for this particular gender, for this particular city, no marks have been assigned yet. So you are
Okay.
assigning the first marks. That means no other female marks has been assigned for physics in this particular city.
Okay.
So if there was already a marks assigned for physics for this particular gender, that means we already found a female card from this exact city and we assigned their physics marks already before this card.
Okay,
In
ma'am.
that case, I will have to compare the marks. So that's what I'm comparing. That the marks that is already stored for this gender in this city, is it greater than my current card physics marks? If it is greater, then I will replace because my goal is to find the lowest physics marks. So what
Okay.
does that tell you statement one should be? So we have to check that is this gender a key of the
Hmm.
particular city dictionary, right? So this
Yes.
statement should be checking is key uh, city D X town city and the particular gender X dot gender. That means is there already an entry for this gender in this city or not? That means if it is already a key, that means some marks is already present for this gender, then we go for comparison. Otherwise, we just create the key.
Okay, ma'am.
Up to this, is it clear for everyone?
Yes, ma'am.
Others?
Yes, ma'am.
Clear, right?
Yes, ma'am.
Okay. So that's what is happening here, the comparison part and the signing. Now, if you are finding a card which is a completely new city itself, for which there is no entry in CTD dictionary itself, right? So for that, then you have to create that entry. That means if this if statement at line 4, if this line 4 if statement is invalid, that is this current town city is not a key of CTD dictionary. In that case, you come to the else statement. So when it is not a city, what do? We create a city, right? We create the new key for that new city. So it will look like what? What should statement 2 look like? To create the city, let's say I have a card where the city is, let's say, Bangalore. So for Bangalore, currently I haven't seen any cards before this. So this is a completely new city. Okay. So for this city, now what should I do? Create. So city D what will you do? Put this current city Bangalore, create a new key, right? And against that key, what is the value stored against each key? A dictionary of this format. So you have to initialize another dictionary as the value, empty dictionary. Then what should I do? For the current card, I check what is the gender and I assign the physics marks for that because this is the first entry for this city. So there is no comparison required. So you can simply write city D, Bangalore. Whatever is the gender in your card, x dot gender, for that gender, the value you store is x dot physics. Is it clear why I wrote these two lines?
Yes, ma'am.
Okay, so you just have to think like this. See, this didn't, let's now first match with options. So statement 1 is saying, is key city D X gender? So is that correct? No. Yes, no. Anything?
No, ma'am.
No. Why? Because city D itself isn't enough. The gender is what? A key of an inner dictionary for a particular city. So city D of what city? That is, you have to give this X town city also. Option A cannot be correct. Option B is saying is key city D X town city X dot gender. First statement is correct. Second statement, if the town city is a new town city and for that no key has been created yet. So you have to create a key. So city dx dot town city and a new empty dictionary for this particular city is now initialized. And statement 3, whatever your current card is, whatever the gender is, take that gender and assign the value. Is option B exactly equal to what I've done?
Yes, ma'am.
So option B seems to be correct. Let's see the other options also. In this option, what is wrong? First, we have to create the
Statement 2 and 3.
correct. So first we have to create the key, then we can populate the dictionary, right? So the statements are in different orders, which is wrong. Option D, it is clearly wrong. Obviously, statement 3 not required is the big signal that it's wrong. Also, this is wrong. Now, let's see. So option B is the answer. Yes. Now, any doubt in this question? Okay, so this type of question, if you just solve on your own, you won't even need the options. So don't go for options
Ma'am,
at
can
first.
you explain line number 5? Like in other question, how can we identify that we have to
Look,
put?
what did I do? Like, how did I understand that what the if statement should contain, right? So for that, I check the else. What is the else doing? So for this if, the corresponding else is this at line 10, where I'm saying that they're assigning marks for a gender. So I am assigning means what? There is nothing to compare. That means for this gender, this is the first time that I have seen this gender for this town city. So there is nothing to compare, right? We are doing gender wise comparison. So that means what? This if statement, if it is true, then I see that there are comparisons. So that means if the gender is already a key for this town city, if I have already seen a card for this gender in this particular city. So that's how I figured out that it should be an is key statement, that I'm checking whether this gender is already a key. If it isn't a key, then it will come to the else part and assign the key value pair. Otherwise, if it is already a key, you have to do the comparison. Clear?
Okay, ma'am, got it.
Okay. Question 4.
Did you
Following
share this
pseudocode.
PDF, ma'am?
No, I haven't shared. Do you want this PDF? I can share it at the end of the class. Okay. The following pseudocode is executed using words dataset. Words dataset. Let unique L, unique is a procedure obviously. So let unique of L return the list of unique elements of L. At the end of execution, W count represents dictionary with words. See, pay attention to this. W count represents a dictionary where words are keys Mapped to what? Number of sentences in which the word is present. That means all the keys are distinct words and the corresponding value is number of sentences in which they are present. Right. So choose the correct code fragment to complete the pseudocode. Ignore uppercase, lowercase. So it is not case sensitive and punctuation symbols are also ignored. So L is what? What is L from this question?
Ma'am, length of the sentence.
No, L is just, see, L is a list that I'm passing or something like that, which I'm passing to this unique procedure, which returns a list of unique elements of L. Right. So that means L is a list containing elements. Okay. L is a list containing, if you pass any list L through this unique procedure, then it will just give you the unique elements. It will remove the duplicate. So this line is important to understand what the unique procedure does to a list. Okay. Now we'll see how it is used in the context of this particular program. So our goal is what? That we have to create a dictionary W count, which will go through this entire words data set and create a dictionary where the keys are unique words, which are mapped to the number of sentences in which they have been used. Clear? So W list is a list, empty list. W count is the dictionary we are building. So while table 1 has more rows, so now in this while loop, you will go through all of the cards in words data set. So you read the first row from table 1. What are you doing? You are adding every word that you read to this W list. Correct. See, before any condition, you are adding it to the W list. That means every single word from words dataset is going to be present in W list. Now, after adding each word, you're going to check if word ends with a full stop. That is, if word is at the end of a sentence. If yes, then you run this part of the code up to this line 14. If you are at a word which is at the end of a sentence. Otherwise, this part of the code doesn't run for every iteration. But if you're at the end of a sentence, then in unique list, another variable, you store unique of W list. What does unique of W list return?
Unique of word list, ma'am.
That means unique elements from this current W list will be stored in unique list. Now for each word in unique list, you do something here. Okay. And then W list is reassigned as an empty list. So from this, I can understand that at the end of every sentence, this W list is going to be reinitialized to an empty list, right? W list is going to be reinitialized as an empty list. So what am I doing? In these lines, line 9 to 11, what is happening? So this is where you populate your W count dictionary. So understand it like this. I read a sentence. Okay, let's say it has some 3-4 words. So let's say even if it has 10 words. Okay, so all 10 words are present in the current W list, right? And then as soon as I reach the last word, then I run this procedure, unique of W list. This will take out only the unique words from that sentence, from your current sentence, from W list and store them in another variable called unique list. Similarly, in the form of a list only. Now you go through each of those words in unique list. So what is your task now? To populate the W count dictionary. That means for each word in unique list, what should I do? I should check whether that word is already a key in the W count dictionary. Yes or no? Because W count words are what? Unique keys. So there should be one such statement like this, that if is key of W count and your current word. That is, your current word is a key of W count dictionary already or not. If it is not, if it is a key, then what will you do?
Then we'll create a new.
If it is a key, then you don't need to create, right? If it is already a key, then you
Sorry,
just
ma'am,
have
I
to
thought
update the count.
Then we add in W list.
Right. So, okay, let's deal with the case if it is not a key. If it is a new word that I've seen, in that case, this will fail. And in the else part, so I will now form a key for this word. So W count of current word. So this is the first appearance of this word. So value assigned will be 1. Otherwise, next time you encounter the same word, this is key statement will be true. And what will you do to the value? same W count of word, except you just increment it by 1, right?
And double plus or single plus?
This is just a plus equal to. This means just increment. Okay. Plus equal to operator. That means whatever is the current value stored in this W count word, just increment that value by 1. So every time you see a repetition of this value, you can increment by 1. So I think this is what this code should look like. So any doubt until now?
No, ma'am.
Let's check what the options are. First option is saying, okay, so since this is a list, I'm sorry, it shouldn't be. No, W count is a dictionary, right? Okay, I think this is true. Yeah. So from this first option, what can you see is the first thing that is wrong?
Member,
Ma'am, word count.
it should be key.
Member.
We are talking.
First
it
of
should
all,
be-
we are checking for W count if it is a key of W count. So why am I
Yes.
checking whether it is a member of W list? This is wrong. You are going to check if the word is already a key of W count. In that case, you don't need to create a new key for this word. You can just increment the value. See, this thing only I have written as plus equal to. Okay, this can be written like this. Okay, so this option A is wrong. This is saying if is key, then you assign 1, else you increment by 1. Is this correct?
No, ma'am.
This is also wrong. Option C, if not is key, that is if it is not a key, then increment. Otherwise, assign.
No,
This is
ma'am.
also
No, ma'am.
wrong.
This is wrong,
This,
ma'am.
this and this are basically similar things, right? Option B and C are doing the same thing. If is key, then you increment. Otherwise, you create a key. If it is already a key, then we increment. So option D is correct answer. So this is the same thing as what I wrote here, right? Is it clear for everyone, this question?
Yes, ma'am.
Yes, ma'am.
Where are the graph questions? 1 second. Okay, yeah. So 2 more. The following pseudocode is executed using sports dataset. What will Z represent at the end of execution? So this is a pretty big code. Let's see. We have to find out what Z represents. So initially I can see that D is an empty dictionary, A is 0, C is 0, while table 1 has more rows. So now let's first understand where all the blocks are. Okay. So from in here I can see there is an if statement which starts here and ends here. So I'm using a single tick mark to get that where this starts, where this ends. And for this if there is the else statement present here which starts here, ends here. And there are no other if else statements. So the while loop starts here, I'm using double tick and ends here. Okay. And inside this for each block also I can see there is an if statement, starts here, ends here. For each block starts here, ends here. Okay, so marking this down will help you understand the code block by block. You don't get confused. Okay. So first we will run the while loop. So the while loop will go through all the cards in the scores data set. And every time it reads a card, what it does, it adds the total marks of that card to A and increments C by 1. So from here, can I say that at the end of execution, C will be carrying the count of how many cards are there in scores data set?
Yes, ma'am.
And A is what?
Total mark.
marks.
Sum of total marks of all students, right? Now in line 7, we are checking that for a particular card that I have picked, I'm checking whether the town city of that card is already a key of dictionary D. From this, I can understand that D is a dictionary where the keys are the town cities, right? So if it is already a key, then I enter the if block. Inside this, I see that then DX town city. Now I can see a nesting here, right? How many keys are there for every such town city I can see? That means for every town city, which is a key, x dot town city, there is a nested dictionary present. That's why this second third bracket is coming. The second key is coming from. So how many such keys can you see here for a particular town city? 2 keys I can see.
2 keys.
One is total, this one is count. That means for every town city, there is a nested dictionary which again contains 2 keys, total and count. So what are they storing? See, if your current card's town city is already a key of dictionary D, no need to create a new key. You just update the inner keys, right? So total is updated by the current total plus the current card total. That means you keep on adding the total. So what is total representing for a particular town city? The sum of total marks from that town city. Correct? Yes or no?
Yes,
Ma'am, this is irrespective of gender, right?
Yeah, irrespective of gender. So every time you find a student from that town city, you add their
Can
total
you
marks.
explain the 8 and 9 once again?
Which line?
8 and 9.
Yeah, see. From here, I can see that D is a dictionary for which the town city is the key, right? That means for D, unique keys are unique town or city names. But from the line 8, you can see that I have a nested dictionary present because D X town city and then I have one more key here, total. That means for every town city, the corresponding value is nothing but a nested dictionary of this sort, where total is a key and count is a key. From 8 and 9 line, you can figure this out by seeing this pattern. Right. Now I'm saying that what is this storing, this total for every town city? It is storing the sum of total marks of all students from that city. And what is count storing? Now from here, you can understand what is count storing for every city.
Number of students.
Number of students from that city. Because for every card, you are just incrementing the count by 1. So that means D dictionary is of what format? D dictionary is like this. Let's say for a particular city, let's take Bangalore only. So for D of
Ma'am, can
Bangalore,
we say dictionaries to total marks of each subject and total students count from the city?
total marks. There is no subject-wise division here. Okay.
Ma'am,
This
I'm
is the
just
total mark.
generate total marks from the
Yeah.
city.
So we just
And
generate the
total
sum of total marks from each city. Okay. And that is stored where in the total key for that city. Like I said, for Bangalore, if I see, the nested dictionary is like this. Total marks of students in Bangalore. So whatever that is, and total count of students in Bangalore.
Ma'am, I have a doubt.
Yeah.
Like in line number 12 in else part, we are creating a new key and values. Then
Yeah.
it's what will
So
the
when is,
impact of code?
yeah, so
Like
you tell
it will
me,
added or it update out?
no, you first tell me if I go to else part, that means the if condition is invalid.
Yes, ma'am.
So if condition is invalid, what can I say? That this town city currently that I have in my card is not already a key of dictionary D. So I have to
Yes, ma'am.
create the key. So that's what you're doing. You're creating a key and you're creating the corresponding nested dictionary also. So since you have only one card, so you put that card's total marks as the total and count is 1 because this is the first card you have seen from this city. Now next time when you pick up a second card from the same city, you will add the total marks to this total and count will be incremented by 1.
Like
Clear?
my doubt is on the old code. What is the impact of it on that code? Like our
Which
previous
one?
code,
Okay, this
previous code.
question. This one.
No, no. I'm saying that I was sorry. Our previous dictionary, like we have a dictionary and we are adding a new key and value.
Hmm.
Then what is the impact on it?
This is the same dictionary only. There is only one dictionary D, which is a
Yeah.
nested dictionary. So for D dictionary, the outer keys are the town city names, unique town city names. For each town city, there is another inner nested dictionary, which contains these two
Okay.
keys, total and count.
Okay, I'm sorry.
Okay. Okay. So this is how the D dictionary is going to be populated in this while loop. So while loop is just to populate the dictionary.
Ma'am, can you explain again line number 8 and 9?
See, for a particular city, if I see that that city is already a key of dictionary D, that means what? I have already seen students from this city. So I have already created a key. That means this structure is already present for this particular town city, right? Now the current card that you are seeing, it also belongs to the same town city. So you don't have to create a new key. You just update the current keys. Just update the current value part, this one, total and count. So in the total, you will be adding the current card's total, and in the count, you have to increment by 1 because you have seen one more card from this city. Understood?
Yes, ma'am.
So after the dictionary has been populated, now you come out of the while loop in line 15. And in average variable, you're storing what? A by C. So what is A? You told me A is the sum of total marks of all students, regardless of city or anything. And C is the sum of, C is the count of students, how many
All-
students there are in school.
All count.
All count. So what is A by C?
Ma'am,
Average
average
of-
marks.
Average total marks of the
Total
entire
marks.
data set.
Yes.
So average is average total marks of entire data set. Now you have another variable z which is assigned 0. So this is what we have to figure out, that what does z represent at the end. So now for each b in keys of D, what are the keys of D?
Town cities.
Town cities.
Town cities. So for every town city we are checking that for that town city, now we are adding a new key in the nested dictionary. Earlier there were two keys, total and count. Now we are adding another key like this, average. The average key is going to be populated here. So what should be the average for a particular city? The total by count for that city. Right. So we already have total and count for every city. So just divide. That is, for that city, divide the total by the count. So D of B of total, B is the city name. D of B of total by D of B of count. This will generate the average which you're storing in the average key. Next, in the if statement, you're checking if the average is less than the total average of the entire data set. That means
Ma'am,
if
this
a
is for
particular,
total of that particular city, isn't it?
yeah.
That means if
The-
if from Chennai, if 5 students are there, so we are,
Yeah.
I mean, total of that 5 students and divided by
by 5.
5.
Yeah.
Yeah.
That is stored in this line 20. Okay, line 20 is to populate that average for every city. Now in line 21, you're checking for every city, the average that you just calculated, if it is less than the overall average that you have stored here in line 16. If it is less than overall average, then what is happening in Z? We are adding the count. That means what is Z? Now from here you can tell. Count is number of students from a particular city. For which cities am I adding the count to Z? The cities
No,
where the
particular
total
city.
average is, the cities where the average is less than the average of the entire data set. So what does Z represent? Number of students
have low marks than average.
this can be worded in different ways. Let me just say that from what I understand, number of students who belong from
So-
cities where average total is less than average total of
All cities.
entire data set.
Yeah, I mean, entire.
Yeah, or you can say for all cities. Okay. So this is what Z represents. Now you have to see which option is closest to this. The first is saying number of students from cities with average total marks of the city more than the average total marks of the
No,
data set.
No, ma'am.
No.
Second option.
Second one, less than the average total marks of the data set. This
Second
is
option.
correct.
Yes.
Let's see the other two also. Number of cities with average total marks less than average. Number of cities is wrong. It is number of students. So last two options you can directly eliminate. So B is the correct option.
Ma'am, fourth option, we can't see it.
This is the fourth one.
Yeah.
Option D. So both are starting with number of cities. So from this you can eliminate this is number of students, right?
Yes, yes. Since we are counting the number of students, not cities.
Yeah. So we are taking count, which is number of students from a particular city. Is it clear for everyone?
Yes, ma'am.
Yes, ma'am.
So can you tell me that if I wanted to calculate the number of cities having average total marks less, then what should I have changed if I wanted Z to represent that?
Mm,
Can you
pardon,
repeat
ma'am?
the question?
Yes, ma'am.
I'm saying that if I wanted to find out, if I wanted this one to be true, this option C to be true, that is Z represents option C, then how the code should be changed?
Ma'am, then greater than, instead of greater than, we have to smaller than, we have to do greater than average.
Read the option carefully. It is saying number of cities with average total marks less than the average total marks of the data set. It has nothing to do with the comparison. You have to
Like,
calculate the number of cities. How do you do that?
Number of
ma'am,
cities. So instead of number of students, we will count the number of cities.
Yeah,
like
so tell me where the change will be in the code.
in line number 19,
19. Why?
No,
like there we
ma'am,
will,
line number
19 is not correct, that I can tell you.
then line number 22, I guess.
So 22, what should be the change?
On the key value of count, we will add cities. Sorry, key.
See, think very simply. I have found a city whose average is less than the total average. So I want to add 1 for that city. That means Z is equal to Z plus 1. I can write. Is this correct? Every time this condition is satisfied for a city, I want to add that city to my Z, right? So just increment Z by 1, that I have found one more such city.
Okay, that time we
Okay,
will
ma'am.
get number of cities.
Yes. So just if you change this code with Z equal to Z plus
Because
1, that is
D
number of
is
cities.
unique for each city.
Correct. Alright. So this type of question can come. This is important. Okay. Now question 6. This is an MSQ. So consider following pseudocode is executed again using words dataset. A is 0, flag is true. In list is empty list, out list is empty list. While table 1 has more rows, read the first row in table 1. So let's again mark down the different blocks. This if statement ends here. This if statement ends here. This while loop ends here. Okay. That means the while loop will go through all of the cards in words dataset. So one by one, as we pick the cards, what happens, we'll see for every card. So for every card you pick, first you check what is the flag. If flag is true, that means if flag value is true, then the if will be valid in line 5 and you can enter and do whatever code is here. If flag is not true, if flag is false, in that case, this part of the code will not be executed. Okay, so what is happening if it is getting executed, if flag is true, then in list, we are doing what?
Storing the word.
Adding the word.
Are we adding or are we simply storing?
Storing it.
Simply storing, right? It is not
Yes.
adding a new word. It is simply storing. And once you store a word, you put flag as false. Okay. Now,
Okay.
in the if statement next to it, that is line 9, what am I checking? If X word ends with a full stop. So this if statement I'll only come to when I'm at the end of a sentence. Only then this will be valid.
The last
So
word.
right, at the last word of a sentence, this becomes valid. So you enter the if block. In out list, now this is adding, right? You have this append symbol. So in out list, what you are appending? The current in list.
Means the first word and the last word.
The last word.
Correct. So that means for a particular sentence, the first word, whenever I come to the first word, the flag is true because flag is being set to true here. Right. So flag will be true for the first word. Once you enter that first word in list, then flag becomes false. And then it remains false until you reach the last word. So again, in the last word, you can enter the second if statement. Here, what you're doing in out list, you're appending this part. So this part is nothing but in list, you're first appending the last word of the sentence. So in list contains first word, last word for a particular sentence. Now for
Okay.
all sentences, this first word, last word list is added to out list.
Pair
Out
of
list
the
is a list of lists.
containing pair of the first and last word of a sentence.
First and last for every sentence. This inner list is the in list. For every sentence, there is an in list, and the total overall outer list is the out list.
Okay.
Now, more things are happening. That is, every time I reach the end of a sentence, I update out list like this, and A is incremented by 1. Okay. And in list is again obviously reset because in list has to be empty before
Yes.
you start for a new sentence, and flag is reset to true. True. So, what is A representing? I can say
Number of sentences.
number
we
of
have
sentences.
seen, yes.
Correct. Now, which of the following are true? These are true. A represents number of sentences in words dataset.
Yes.
True.
I think
Yes.
A represents number of words is wrong. It is at the end of a sentence. You only increment A.
Here applies number of sentences.
Yes. So option A is correct. Option B is false.
and
Option C.
also D.
Okay, let's see why C is wrong. Outlist represents list of lists of last and first words of each sentence in that order. No.
It's
First, the
first
first
and
word is
last.
included, right? Then you are appending the last word from the end of it. So option
So
C is wrong.
option D is
List of
correct.
lists of first and last word in that order. This is correct. So A and D are correct. Clear for everyone?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Ma'am, in enlist, what we are storing?
In list, we are storing, see, for every sentence in the dataset, there is an in list in which we are storing the first and last words of that sentence in this particular order. Okay.
Where it
So
is
first the
written is the first and last, how we can get to know the first and last word storing in
So
enlist?
isn't that what you're doing? For every sentence, the flag is set to true for the first word. Then in list, we are storing the first word of that sentence. Now flag becomes false. And after this, flag will only become true when you reach the last word of that particular sentence. That is, X word ends with a full stop. Then you are
Okay,
taking that last word and adding it to in list. Right.
okay, thank you.
Okay. Now this question is very easy. Everyone knows what is a click?
Yes, ma'am.
Ma'am,
Yes.
I have a doubt on click.
Okay. Yeah, ask what is the doubt? Is it a question, separate question, or in the concept?
Concept.
So click is nothing but three. A click should contain minimum how many nodes? Anyone tell me?
3.
Three. Okay. Why three?
Because then we can correct the matlab, that we can make that triangle type things.
Ma'am, first what is click?
So a click is nothing but a subgraph of a graph where all nodes are connected with each other. That is, click can be a single node also. Okay, if there are no edges, if there is a single node. Again, it can be larger nodes if it is a pair of nodes. So the both nodes are connected to each other with an edge. It's a click. If it is a group of three nodes, okay, and it is connected like this. So in this graph, if you see node 0, node 6, node 11, that is a click. 0 is connected to both 6 and 11. 6 is connected to both 11 and 0. 11 is connected to both 6 and 0.
Like it's a form, can we say click is a form of triangle?
See, in our definition, in the actual definition of clicks, minimum size depends on font text. Okay. So in our definition, we will say that click is a group of nodes where every node in the group is directly connected to every other node in that same group. So here in this context, we can say that the minimum, what we are saying is a click is a minimum subgraph containing two nodes. Okay. In this drawing, in this particular graph, I can say that a click has minimum two nodes. So the concept of click is that no matter how many nodes are there in your click, every node should be directly connected to every other node.
Every node should be connected to each and every node in its group.
Yeah, directly.
Yeah, direct. Okay, ma'am, directly.
Okay, that means direct edge should be present between every node, every pair of nodes. So now,
here,
But ma'am, 6 is not connected with 5 and 4.
yeah, so that is not a click. It has to be a
Then there
subgraph.
is only one click.
Is it? See clearly. 0, 12, 6. Is it a click? This.
Yes. It forms a loop, ma'am.
So does that mean it's not a click?
Ma'am, it is clicking.
It is click, ma'am.
It is click, ma'am. It is directly
I
connected.
have never said that click cannot be cyclic. It has to be cyclic. Right?
Can't
Again,
click be open?
it can be open like this. If you have only, see, open means if you have only two nodes. In that case, so there is only going to be a single edge. But if you have three nodes, can it be open? Can 0, 4, 5 make a click if 4, 5 is open?
Yes, ma'am.
Oh,
This is not a click. Where is direct edge from 4 to 5 or 5 to 4?
So they can't form.
Click definition. See here
Ma'am,
clearly what I'm saying. Click
0 to 5
definition
can
is
form.
0 to 5 is a click. 0 5 is a click.
0
Okay.
4 is 0 is a click. 0 4.
But
0
4
4
to
is a
5 and
click.
5 to 4 is not possible.
No. Again 0 4 5 is not a click. Click definition, just here the simple definition. Click is any number of nodes or any group of nodes where every node in the group is directly connected to every other node in the same group. Understood?
So 0, 11, 6 is a click.
0 11 6 is a click. 0 12 6 is a click. 0 14 6 is a click. 0 5 is a click. 0 4 is a click.
Yeah, got it.
Okay. So what are the correct statements here? There are 4 clicks of size 3 present in the graph. Size 3 means
Yes,
3
ma'am.
nodes.
Yes, ma'am.
So no. Clearly see
think
first. Are
three
there
clicks.
4
Ma'am,
clicks?
3 clicks are there.
3 clicks are there of size 3. One is
okay,
0 11
sorry,
6.
0
One is
5.
0 12 6.
5 0 6
One
is
is
not. Yes.
yeah. One is 0 14 6. So option 1 is wrong. Option B is saying the nodes 0 11 6 and 12 form a click of size 4. 0 11 6 and 12.
Yes, ma'am.
How can you say 11 to
No,
12 is
because
there an edge?
No, ma'am, there
because
is no
11 and 12
edge
there is no
between
node.
11 and 12.
There is no hurry. Okay, first analyze the question. Analyze the graph properly.
That
This
is
is how you
false.
lose marks. This is a very easy question. You just have to be attentive. Okay, so option B is also wrong. Option C is saying maximum size of click that appears is 3.
It's
Yes,
true.
ma'am.
Yeah,
Yes,
this
ma'am.
is true.
Ma'am, options are not
Maximum.
visible, ma'am. I don't know others can see or
Yeah,
not.
this one. This is the option. You can't see?
All 4 options are not visible. Only 3 options are visible
Now?
from my.
Ma'am.
Yes, now it is
Clearly
visible.
Oh, I was not scrolling down because then the answer would be visible, but it's fine. Okay.
You can hide the answer, ma'am, but only 3 options are like earlier it was showing only 3 options.
Okay.
Okay.
I'll show the whole thing. Okay, so maximum size of click is 3. Is that correct in this graph?
Yes, ma'am.
Yes, ma'am.
We can't find a click of size 4 here. So option C is correct. Nodes 0 and 5 form a click of size 2.
True, ma'am.
Correct?
Ma'am.
So C and D are correct. See, for this easy of a question, you get 5 marks. Nothing to do here. You just have to see the graph and answer. Okay.
Ma'am, I didn't understand the D option. Can you repeat again?
Nodes 0 and 5 form a click of size 2.
One is 0 to 5 and one is 5 to 0, is it?
Yes.
Yeah,
Oh.
so 0 and 5 are connected directly with each other. So it is a click.
Okay.
And the size is 2 because 2 nodes.
So it hasn't to be only cyclic, it can be both.
It can be anything. Okay, it can have 2 nodes, it can have 3 nodes, any number of nodes. Just all the nodes should be connected with each other directly.
Okay, understood.
Can
ma'am.
one node be a click?
Yeah, one node can also be a click. It depends on the context of the graph. Okay. Okay. Question 8. Following pseudocode is executed using library dataset. So A is 0, B is 0, C is false. While table 1 has more rows, read the first row in table 1. So library dataset, the information is about books and authors, right? So you go through, let's again block off the if else statement. So if starts here, ends here, while starts here, ends here. Second while loop starts here. Inside that I can see if statement. So the first if statement starts here, ends here. Second while loop ends here. There is a last if statement which starts here and ends here. This is outside of the while. Okay. So let's see what is the first while loop doing. It is going through all the cards and it is checking if the genre of the card is fiction. In that case, A is incremented by 1. So at the end of first while loop, A is storing what? Number of books from
Genre.
fiction genre.
Fiction genre.
Books. Number of
Okay.
fiction.
Now see, all the books have been moved to table 2. So while loop number 2 is working on table 2 because now all the cards are present in that table. So again, you are going through all the cards in table 2. So you read the card and you check what? If the genre is not fiction and language is English, then B is incremented. So at the end, B is storing what?
Non-fiction plus
Non-fiction.
All the non-fictional English
English
books.
language books.
All the non-fiction books that are written in English. Okay. So which is the bigger set?
A.
We don't know that. Okay, we don't know what is the bigger set. That depends on the data set. So what are we checking in line 17? If set A is a bigger set than B, then C is assigned true. So what does that mean? When will set A be bigger than set B?
If fiction book are
When
more
when the
non-fiction
total
When the
number of
genre is
fiction book is
fiction.
more than total number of
Non-fiction
English.
book which is written in English.
Yes. So when total number of fiction books is greater than the total number of non-fiction books written in English, then C will be set to true. Otherwise, C remains false. So which of the following statements is true? C will be true. See, first option is saying C will be true. You can see all 4 options.
None.
It false.
Yes.
C will be true if there exists more fiction books than non-fiction books.
No,
Here
it's
is
false because
language not.
and the language is also
English
important.
language not
Can't tell. We
included.
can't tell. We can't tell because
Yes.
A is
language
not
is
correct
not
because
included.
A is not correct because there is no word English.
Yeah, because the language parameter is not being considered, so we cannot say. B represents number of non-fiction books. No, non-fiction books written in English.
Yes.
Yes.
Yes, ma'am.
A represents number of fiction books. Yes.
Yes, ma'am.
Yes.
C will be true if there exists more fiction books than non-fiction English books.
Yes.
Again,
Yes, ma'am.
Yes.
C and D are correct. This is
Yes.
clear for everyone, right?
Yes, ma'am.
Very
Yes,
good.
ma'am.
Yes, ma'am.
Okay. Now come to question 9. So let D be a non-empty dictionary. Choose the correct options. This is also an MSQ. So it is a non-empty dictionary. It contains something, some entries. Option A is saying let A be a key of dictionary D. Then A is always an integer.
No, no, no.
No, there is no such thing. Key
It
can be
can be
anything.
string, it can be boolean.
Yeah,
Right.
ma'am.
Key can be anything. So option A is wrong. Option B for keys A and B in dictionary D. If A is not equal to B, then D of A is not equal to D of B is always true. First of all, can A and B be equal?
No.
No,
No,
ma'am.
ma'am.
So all keys have to be
No.
unique, but not necessarily the values also have to be unique, right?
Yes.
Yes, ma'am.
Yes.
So option B is wrong. Option C is saying for keys A and B in dictionary D, A not equal to B is always true. This
Yes.
is
Yes.
correct.
Yes,
All
ma'am.
all keys have to be
Keys
unique.
are always
It can't
unique.
be same.
Okay. Now, last option D, the dictionary is given to you. Then the value of init of DB is 47. So first find out what is D of B. This list 347. What is init of that? 34.
Initial.
47.
3-4.
34.
Except the
Init
last
Init
remove
element.
means what?
last.
See, rest means remove the first element. Init means remove the last element. So it should be 34, not 47.
Yes.
So
Yeah,
this is
ma'am.
also wrong. Answer is C. Okay.
That's for 4 marks.
Yeah, it's for 4 marks. Very easy questions. Okay, this one be a bit attentive. Okay. Consider procedure find something that accepts a non-empty list of integers L as input. Okay. So L is a non-empty list of integers. Now, what is it doing? First, it is checking if length of L is exactly equal to 1. That is, if L contains only one element, then we will return that element, first of L. Right. So here, if I change this with last of L, will it make a difference? If there is
No,
only
no,
one
no, no.
element,
Because there is only one element.
so
It's
first
same,
and last
ma'am.
are both same. So
Yes.
first of all, if there is only one element, you return that element. If the length is greater than one, more than one elements are present, then you come to else part. Else part, what am I checking? If first of L is greater than last of L, then recursively call the function again with init of L. That means if first of L is greater than last of L, that is first element is greater in value than the last element, then last element is removed. And the rest of
Yes.
the list is passed through the procedure again.
Find
And
something.
if first of L, right, if first of L is not greater than last of L, that means it is less than or equal to last of L. Okay, see, it is nowhere written that it is distinct integers. It is just non-empty list. So first and last can be equal also. So if first of L is less than or equal to last of L, then you take out first of L, remove it, and put the rest of the list through the same procedure. So now let's do a list and see what it is actually doing. Let's take this list 1, 2, 3, 4. In this case, first of L is greater than last of L? No. So find something will do what? Take what as parameter? Which element should be removed? 1 is less than 4. So 1 should be removed. See, I'm passing rest of L in that case. So what should I pass? 2, 3, 4. Again in 2, 3, 4, check 2 and 4. Is 2 greater than 4? No. So what will be removed? 2. So next find something. 3, 4.
Yes.
Okay. Now here first and last. Is first greater than last? No.
No.
So remove first.
4.
Find something 4. And now there is only single element, so we'll return that. That means highest element is being returned. Yes or no?
Yes.
Yes, ma'am.
Let's check the other way also. If it was like this 4, 3, 2, 1. In that case, do the comparison. 4 and 1. Is 4 greater than 1? Yes. So
Yeah.
remove 1.
Then we'll
Next
get
call 4, 3, 2.
2.
So
Now we
4
will
greater than 2, remove 2.
Yeah.
Similarly, then remove 3. Again 4 only is returned. So in any
Both
case,
the
it is
cases. Yeah.
largest element.
largest
So now
integer.
largest integer. Okay. So now see the options. Option A is saying procedure finds something finds the largest integer present in the input list.
Yeah, it's
Yes.
correct.
Yes, ma'am.
True.
Okay, now just for curiosity, let me try this. If I write 1, 5, 2, if this is the list. Now compare first and last. Okay. So first and last, what is smaller? First. So remove first.
Yes.
So in this case also, next you are passing 5 and 2. 5 to what is smaller? Last one. So remove
Yes.
last. In this case also, the greater element only is being returned. I showed this because the other two are sorted lists I took. This is an unsorted list, right? Okay. So procedure definitely returns the largest integer present. Second option is saying procedure returns the smallest integer. No. Third option is saying if we replace line 6 to 11 with this code below, procedure will return same output. See what they have done? Just replace the condition. So earlier we were seeing in line 6 to 11, we were checking if first is greater than last. Then return find something init of L. Now they're saying if first is less than last, then return find something rest of L. Is this equal?
False,
This
ma'am.
is
Not
not
equal.
equal.
Also.
Because this first one finds the
Yes.
larger integer present, but the C code does the shortest integer in the function.
So you're saying this is wrong.
So C is wrong.
C is correct.
C is correct.
Why, ma'am? But
Ma'am,
why?
because
They
there is
changed the
return
symbol
value is
only.
also changes.
Look, why isn't it correct? You are just doing the opposite of this here. Here you are saying if first is greater than last, then you return what? Init. You call the
Yes.
procedure with init. Here also same thing is happening. If first is less than last, then you return rest. If first is greater, then you return init.
Okay, so we just change the inequality, so
Yeah,
we need to
just
change
change the inequality and change the return statement. Return statement depends on the inequality. So if you're changing it, the return statement will also be reversed.
They
Ma'am, what
both will
init
get
does,
the
ma'am?
same output.
What about?
What init does?
Init removes the last element from a list.
Okay, ma'am.
Okay, so A and C are both correct. Option D, is it correct? So it is saying if less, then I replace with init. This is not correct.
No.
If
Yes,
first
ma'am.
is the smaller one, then you remove the first one, that is rest of L. Right, whichever is the smaller element, we are trying to remove that. So if first is smaller than last, then remove first. So this should be rest and this should be init. So obviously option D is wrong. So A and C are correct. This is clear for everyone?
Yes, ma'am.
Okay, now the second half of questions. Okay, let me see where the graph questions are starting. I think the last 5 questions are from graph. Yeah, this part. Okay, no issue. So given pseudocode is executed using words dataset, at the end of execution, A captures the frequency count of the most frequent vowel in the dataset. That is how many times the most frequent vowel has appeared in the dataset, that is being captured in A. But the pseudocode may have some mistakes. We have to find out all such mistakes. Okay. Remember, A should capture frequency of the most frequent vowel in the entire dataset. Again, let's check inside the while loop. So where is the first while loop starting here, ending here? For each starting here, ending here. Inside that, there is an if block. And there is a procedure called update dictionary, where I can also see another while loop, which starts here, ends here. If, else. Okay, now let's try to solve. So words data set. So the first, I can see that there is a D empty list D, and A is assigned 0. So while table 1 has more rows, that is we go through all the rows in words dataset, and if for every card that we pick in words dataset, in D variable, what am I assigning? Update dictionary D with X. Right? 2 parameters I'm passing, the list D and the current card X. And the procedure update dictionary is being called. So now we'll see what is update dictionary doing. I think there is something wrong, because this should be a dictionary. It's not a list, right? If you're updating D like this, D of B, that means it is a dictionary. Okay, so consider D is a dictionary. Now, for every card, I am passing this procedure D along with that card. So in the procedure definition check, what is happening? First, I is set to 0. Now, the while loop will run how many times? For a particular word, how many times will the while loop run?
Its letter count value.
If letter count is 5, I starts from 0. How many times is it running?
5 times.
Is it
6 times?
6 times?
6
Because the
times.
equal to its condition is there, right? That means if my letter count is n, the loop will run n plus 1 times. Because there is a less than equal to. If it was strictly less than, then it would be strictly the number of letter count. Okay. So let's take a word. Let's take that same word, soon. What is the letter count? 4.
4.
So I starts with 0. First iteration, let's see what is happening. First iteration, I is 0. 0 is less than 4, correct. Get into the while loop. B is the ith letter in the word. That means 0th letter. So is there a 0th letter? This code is okay. So this was the mistake part, right? This part is the mistake. First of all, I should be initialized with 1, I think. Okay, so we are trying to find mistakes only. Okay, so I should be initialized to 1 as far as I think. And then it should be less than equal to letter count. So I think initialization of I is wrong. That is 13 should have, incorrect initialization of I. This is one thing, because there is no 0th letter in a word, right? We start with I is equal to 1, first letter. So this is wrong. Again, rest of it is fine. Now, if I start with this, if I start with I is equal to 1, then it will be how many iterations? N iterations only. Because 1 less than equal to 4 will run 4 times. For 1, I is equal to 1, 2, 3, and 4. Now, for every I iteration, what am I doing? I'm checking the first letter. Let's say, what is the first letter of soon? S. You're checking if S is not a key of dictionary D. Initially, D is an empty dictionary. So this is my first word, let's say. So if it is not a key, then it is saying increment. Is it correct? If something is not a key of a dictionary, what do? We create the key.
We create a dictionary.
We create a
That means this line should be there.
Yes,
instead of
ma'am.
this line. These two should be reversed. So how can I fix that? Instead of writing if not is key, I can write if is key. If
Yeah.
D is already a key of dictionary D, then increment. That is one more occurrence of this particular letter you are now seeing.
Line 16.
Right? So line 16 conditional expression should not use not operator. Right? Now rest of it looks fine because here you are calculating the occurrence of every letter. This is fine, and then I is being incremented before every new iteration. So this procedure is fine. So I have found two errors here, one in line 16, one in line 13. Another error that we found is D is a dictionary, right? It is not a list. So line 1 is also wrong. Let's see if line 1 is in the question. Yes. Incorrect initialization of D. So what is happening once I correct all of this, when I return D? So D is now keeping correct track of how many times each letter has occurred in the data set. Okay. Now come to this part. Once the while loop is over, that means all the calls to update dictionary procedures are now finished. Now come to the for each block in line 7. For each C in keys of D. So what are the keys of D? Unique letters. Yes or
Unique
no?
vowel.
That is, look, unique letters. Here are in the procedure update dictionary, are we checking for vowel anywhere? We are checking for all letters.
Yes, ma'am.
That means D dictionary contains keys what? All unique letters. All unique letters are keys of dictionary D. So you go through each of those letters. In keys of D, you have all the letters present. Then you check if C is a vowel, that is the current letter you have picked is a vowel or not. And D of C is greater than A. That is greater than 0. A is initialized to 0. Right. So every time you find a frequency higher than 0, you assign it that. And then for the next comparison, you again compare with A. So like this, which are the letters I'm comparing? Only the vowels. And every time I find a vowel with a higher frequency than the current A, I'm assigning that frequency to A. So A is storing what at the end of the day? The vowel which occurs with the highest frequency. Rest of the code, can we find any more mistakes other than the 3 I've pointed out?
Ma'am, so it is not storing all the vowels, but it is only storing that vowel which is having greatest frequency.
No. It is not storing the vowel, it is storing the frequency in which that maximum frequency, the vowel
Yes,
that has
ma'am.
occurred.
Ma'am, I
Okay, so
understood.
not the vowel itself, just the frequency.
So the highest frequency it is storing.
Yes.
Okay.
So that is what A should capture. See, in the question, A captures the frequency count of the most frequent vowel in the data set. So that is happening. So any
Yes,
other
ma'am.
mistakes can you see in the code? Anyone? Other than line 1, line 13, and line 16. So there are no other mistakes. See, A, D, and E are the correct options. This one was clear for you. Any doubt? Everyone understood?
Yes, ma'am.
Yes, ma'am.
So the code is wrong, ma'am.
Yeah, that's the question. No? See, the pseudocode may have some mistakes. So you have to identify the mistakes. That's what I did. First mistake was at line 1 that you are calling update dictionary, where you can see that clearly D is a dictionary. That's why you are having key value pairs. So D cannot be initialized as a list. It has to be initialized as dictionary. Later, I told you why I cannot be 0, because you want to go through all the letters in a particular word. So I has to start with 1, which is the first letter. And again, another one is the is key one, not is key, and then you are updating directly. If something is not a key of a dictionary, how can it have a value? If something is not a key, then you first create the key. So that's why I removed the not. Okay. These 3 were the mistakes. Okay, question 12. This is executed on shopping bills dataset. Assume each customer has distinct name. So A is 1, N is 1000, count is 0. So while table 1 has more rows, read the first row in table 1. This statement is important. Okay, assume each customer has a distinct name. So no customers can have same name. A is 1, N is 1000, count is 0. Again, see, if statements, first let's block off them. If statement starts here, ends here. Else for this if starts here, ends here. This bracket is the bracket of this while loop, inner while. Okay. So I'm using double ticks. And this outer while, I'm using 3 ticks. It ends here at the end. And there is one more if statement. Okay, now see. Read the first row X in table 1, move X to table 2. So every time you read a card from the shopping bills dataset, you move it to table 2. Then there is an inner while. So for every card we pick in the outer while loop, we come to the inner while loop. And while table 1 has more rows, so you pick another card. So now you have 2 cards, X and Y. So you compare the customer names. If the customer names are exactly equal, see, there can be 2 cards with same names, right? Why? In shopping bills dataset, 2 cards can have the same name of a customer. Why?
They may shop in different shops.
Right. So they have shopped from different shops. The single person has 2 or 3 different bills from 3 different shops. So it is possible to get such a pair of cards from the same person. So if both the cards that you have picked are from the same person, that is what you're checking in line 7, then you increment A by 1 and move the second card to table 2. If the second card you picked is not from the same customer as the first card, then you move the second card to table 3. So now you tell me, for every card that I pick here in the outer loop, in the inner loop, what am I doing? I'm comparing that card with every other card to find out that where I can see the matches, that how many cards are there from this particular customer. So if a particular person has, let's say, 3 cards shopped from 3 different stores. A was initialized to 1. When I pick that person's card in the outer while loop and then come to the inner while, how many times will A be incremented if the person has total 3 cards from 3 different stores?
4 times.
Four times, ma'am.
Why?
Ma'am,
Different
because
store.
we already
You
implemented
have
1.
no,
Sorry,
listen.
ma'am. 3.
You already have 3 cards only, exactly 3
Yes,
cards
ma'am.
from a
Now I
particular
got.
person. Okay, so you already have picked 1 card. How many are remaining? 2.
2.
So you will find exactly 2 matches. A will be incremented exactly 2 more times. A will become 3. Right? That's what you're doing in the inner while, comparing 1 card with every other card to find that how many cards a single person has. Okay, so the inner while ends here. Now, after the inner while is over for a particular X card, you come out of the inner while loop and you check if A is less than N. And then you assign the new A to N. N is 1000, it is a much higher value, so that we can find, so that all A's will be less than N, right? So it is set to some high value. So for that customer that I said that has 3 cards, A value at the end of execution of inner while loop will be 3. A was initially 1, incremented 2 more times, so A is now 3. So 3 is less than 1000, yes. So N is now 3. Okay. Now let's say for some person, that person has 2 cards. So you have picked 1 card and another match you will find in the inner while. So for that person, what will be the A value?
2, ma'am.
2.
2.
2. See, A is always getting reinitialized here. Okay. So then for the next iteration, when I come to this comparison, now N is 3, A is 2. 2 less than 3, so N is set to 2. Okay. Now after this comparison, we come out and we reassign A to 1 and count is incremented by 1. So now we understand that what is N storing. What is N storing? You tell me.
The minimum value.
Of what?
Customer who have shopped from the different
So the least
shop.
number of cards from a
Yeah.
particular customer, right? Least
Yeah,
number
ma'am.
of shops that a particular person has shopped from. Count, what is count?
Total number of cards in the shopping bills.
Is it? Aren't you all also removing
Total
cards in
number
the
of
inner while
persons.
loop? What about the inner while loop? There you are also removing cards. Wherever you find a match, you move it to table 2. If you don't find a match, you move it to table 3. See, from table 3, I'm retrieving the cards, but from table 2, am I retrieving anywhere? That means the cards from the same person, wherever I find a match, am I again checking for that card? No. So count is what? Number of distinct customers. Look at this part in
Okay, ma'am,
line
got
9.
it.
Every time you find a match with a card, you move it to table 2, right? You don't check again for that particular card. Anything that goes to table 2 is never retrieved. That's why X is also sent to table 2. All the matches of X are also sent to table 2. Only the ones that go to table 3 are retrieved. Move all rows from table 3 back to table 1. So that you have the distinct customers, so that you have the other customers again back in table 1. So that means count is what? Distinct customers from the entire shopping bills data set. So which of these options are true? N represents minimum number of bills issued to a single customer. Correct?
Yes,
Correct.
that's correct.
Yes, ma'am.
Count represents number of customers.
That's also correct.
Yes,
Also
ma'am.
correct. A represents maximum number of bills issued to a single customer. Does A represent that? A doesn't represent anything. A keeps changing.
But
He
ma'am,
assigns
for a-
one again and again.
For a particular customer, it gets reassigned. So at the end of execution, we are asking what is true at the end of execution. At the end, A doesn't represent anything. We cannot tell what A will represent. Right? Because A keeps changing for every customer. So option C cannot be correct.
Ma'am, how option B? Because you said number of customers should be unique, no?
Yeah, so now count represents number of customers. So that means unique customers only. Why will I take duplicate customers?
Okay.
Okay. Option D is saying if we replace line 16, that is this line, with n is equal to n plus 1, that is we increment n simply, then n will represent number of bills issued to a single customer. That is absurd. That doesn't make any sense. If I increment n by 1 every time I find an a less than n, that does not necessarily mean it will represent number of bills issued to a single customer, right? N can be anything. For example, let's say n was 2. Next time I found a customer for whom A is 1, that is that person only has one bill, then 1 is less than 2. So if I increment n by 1, n becomes 3. That is not the number of bills issued to that customer, right? It has nothing to do with it. So option D is also wrong. Only A and B are correct. Is this question clear?
Yes,
Yeah.
ma'am.
Okay. Now question 13. What will be the value of S at the end of execution? L1, L2 are given to you. S is calling this procedure do something, which takes these two lists as argument. So procedure do something takes X and Y as argument. If length of X is not equal to length of Y, then return 0. Is length not equal?
false.
L1 and L2 have same length. So first if statement doesn't work. Come to second if. If length of X is exactly equal to 0 and length of Y is exactly equal to 0, then return 0. This is also wrong. If both if statements are wrong, then you have to come to this line 12 eventually, which is the return statement. What is it returning? This is a recursive call. So now let's write this first recursive call. So return what? First of X. What is first of X? That is L1.
2.
2.
2 into last of Y. That is L2.
2.
2.
So 2 into 2 plus do something of what you are passing is rest of X and init of Y. So rest of X is what? Remove the first element.
Remove the
Minus
first
Minus
one.
5.
Minus 1.
init of Y. Init of Y.
3, 4.
First
3 and 4.
3, 4.
So now this is the second recursive call. Now move the control here. Is the length equal of both lists?
Yes,
Yes.
Yes, ma'am.
Are
Yes.
any of the lengths equal to 0?
No.
No. So again, the recursive call will be returned. So what is first of X now?
Minus
Minus
1.
1.
Last of Y
4.
4.
4.
plus do something of what is rest of X now?
5.
5.
5.
5 and 3.
5. Init of Y is
3.
3.
3. Good. So now third recursive call. Control shifts to this one. Third return statement. So first check, is the length equal? Yes. Length is not 0. Also yes. So come to the recursive call. So what is first of x? 5.
5,
Last of y? 3.
3,
Only one state, only one element.
yeah, 15.
Plus do something when you do. Now rest of x is what? Empty list.
Empty.
Init of y is also empty list. Now when control shifts to this recursive call, which is the fourth one, here the length of both lists is equal, 0. But both lengths are also 0 itself, right? So the second if condition will be true or false?
True.
True. So this part will return what?
Return 0.
0.
0.
Return 0. So fourth call returns 0 back to here. Now in the third call, 5 into 3 plus 0. So this will return what? 15.
15.
Back to the previous call. So this part is
Minus
generating
4.
15 and this is generating minus 4. So 15 plus minus 4 is 11.
11.
11 back to the first call. 11 plus 2 into 2,
4,
4. That is 15.
15.
So that is your answer. 15. Clear?
Ma'am, can you give the overview of what happened?
This is just a recursive call. That means every time you are comparing two lists, you're checking if they're of the same length. It is fine. And if both of them are non-empty, then you will go to the recursive statement, that is last return statement. And you will keep calling the last return statement until both the lists become empty. So
Okay,
at
ma'am.
that point, that is the last call. That will return 0. Then you just trace back. Clear
Okay,
for
ma'am.
everyone?
Yes, ma'am.
Okay. Question 14. Given pseudocode is executed using dataset having the same fields as words dataset. So it is not exactly the words dataset, but it is similar to words dataset. That is this paragraph that's given. Consider the information that unique is a procedure which takes a list as input. And what does it return? Unique elements in that list. For example, if we pass this list, think like toppers thing. So unique procedure will return think like toppers. So only the unique words. Common number of L1 and L2. So common number is a procedure that takes both lists and returns number of common elements in lists 1 and 2. Again, case sensitive, you can ignore, no case sensitivity, ignore upper and lower case and punctuation symbols as well while comparing with other words. Okay. So this type of question we solved last class also. Positive list contains list of positive words. Pos_sen, that is number of positive sentences will be stored here. That is initialized to 0. List is initialized to empty list. L is an empty list. Now, while table 1 has more rows, so you will go through all the words in this paragraph that is given to you. Okay, let's block off the if statements. Here the if is starting and ending. We have one more if. Outer if starts here, ends here. Let's add 2 tick marks. This is the while loop. Starts here, ends here. So inside the while loop, we are going through all the words in the given paragraph. What am I checking for every word? First, you read the word. Every time you read a word, it is appended to L. When is this if condition will be satisfied? When you are at the end of a sentence. That is X ends with full stop. You are at the end of a sentence. At this point, L contains what? All the words in that sentence. Now, if you pass L through the unique procedure, what will it return?
All the unique words.
Unique words in that sentence. That is now stored in L. That is the new L. Now, positive count is a variable which contains whatever is returned by this common number procedure where we pass positive list and the current L. So positive list is given to you, current L is also given to you. So let's find out what is the first sentence. The experience was simply wonderful. This is the first sentence. All are unique words. So this list of words will be passed along with this positive list into common number procedure. So how many common words can you see between these two lists?
1.
Wonderful, right? Wonderful is the only common one. So pos count is now 1. Pos count, is it greater than equal to 2?
No, ma'am.
No.
No. So I cannot say it's a positive sentence. So pos_sen will not be incremented. Again, the list is now L is now reinitialized to an empty list for the next
Empty.
sentence.
Yes, ma'am.
So now you again start for the next sentence. Check. The product quality is fantastic and I would definitely recommend it to others. Now you pick out all the unique words from this sentence, whatever it is. And you have to match the unique word list with this positive list and find out how many common elements. How many common fantastic is
One.
present?
One only.
Ma'am, only fantastic.
Nothing else is there, right? No. So for this statement also, is the positive count greater than or equal to 2?
No, ma'am.
No.
No, ma'am.
So first sentence is not being incremented. First sentence is still 0. Third, it is not only affordable but also an excellent design. Affordable and
Excellent.
2.
Excellent. It's equal to 2, ma'am.
so
It
this
will increment.
statement is now true. 2 greater than or equal to 2. So positive sentence was initially 0, now it is 1.
One.
So we found one positive sentence. Now the last sentence is what? Overall, I believe it is a great choice for anyone looking for a reliable product. How many positive words?
2.
Great and reliable.
Yes, ma'am.
2, ma'am.
2 words. So again, positive sentence will be incremented by 1. So 1 plus 1, 2. How many total positive sentences I got? 2.
2, ma'am.
So answer is 2. What will be the value of first and at the end of execution? Clear for everyone?
Yes, ma'am.
Yes, ma'am.
Now 15 and 16 are comprehension type. So this is the last this type of question. After this we have graphs. I think this is also sort of a matrix only. Yeah, this is also a graph. So after this from 15 to 20 all are graph questions. Okay. So consider a graph generated from scores table that is represented by a matrix B. Everyone knows how to generate matrix from graph. What is adjacency matrix?
Yes, ma'am.
Yes, ma'am.
Right. That means if between any two pairs, I can see there is an edge present in the graph, then in the matrix also, that row and that column in that particular cell, the entry should be 1. Otherwise, 0.
Yes, ma'am.
Yes, ma'am.
So each node, so the matrix is B, each node in the graph corresponds to a student from the table. So as many unique students, that many unique nodes in the graph. Sequence number is used to label the nodes in the graph. So sequence numbers are allotted to each of the cards, right? So that sequence number is the nodes basically. Study the given pseudocode and answer the questions. So what is happening here? A is an empty dictionary, right? Now, again, let's do the blocking. While loop starts here. Okay, first, while loop starts here and ends here. Okay, so no need for that many ticks. We can just use one tick. Starts here, ends here. Then again, I have a for each block that starts here. Inside that, one more nested for each that starts here. Another if statement that starts here. So this if ends here. The in the nested for each ends here. Outer for each ends here. In this procedure, there is no need to block. We can easily see the blocks already. One if, one else. So let's see what's happening. First, in this first while loop, you go through all of the cards in table 1. And for every sequence numbers are unique. So A is a dictionary where the keys are what? Unique sequence numbers. Against each unique sequence number, what is the value stored? City, town, and gender in the form of a list. So that's what this is doing. So what is the format of A dictionary?
List.
A dictionary keys are what?
Sequence
number.
number.
Sequence number.
Variables are
Sequence number,
city
ma'am.
and gender.
And every value is a list containing the city and gender of that sequence number, right? Now come to line 7. N contains length of keys of A. That means number of unique students. Number of students. There are only unique students only in scores data set. So number of students that is stored in N. B is what? Create matrix N cross N. So B is the matrix that we created, right? So scores table is represented, consider a graph generated from scores table that is represented by matrix B. So that B matrix is created here. How many nodes are in the graph? As many as there are students. So that's why I found out that there are N students. So the matrix should be of N cross N order. Now, once the matrix is created, you check for each I in keys of A and for each J in keys of A. Okay, That means two distinct students these are. I'm checking if I is not equal to j. First tell me something, that if I pick I, will I be equal to j?
No, ma'am.
No.
So if I is not equal to j and is related, this is a procedure in which I'm passing a of I and a of j. A is this dictionary, right? Let's just write down A, that in A, the entries are of this format: sequence number and city, town, and gender. This is each entry in the A dictionary. So for each I, J pair, we are checking if I is not equal to J and is related. That is, whatever this procedure returns is true. So what is related doing for AI and AJ? So now we have information for two students, city, town, and gender information for two students, I and J. I am checking if first of X. What is first of X? City, town.
City.
Cities.
I am comparing the city, town of both students. First of X and first of Y are exactly equal, or last of X and last of Y are exactly equal. So this means that if both students are from the same city, or both students are from the same gender, or both, right? Since or statement is used, that means all three conditions are correct. If they're from same city, town, if they're of same gender, or both are true. In that case, we'll return true. When will we return false? If they're not from same city and of different genders. Only then false will be returned. Right? So this true false is being returned where? Here. Now, if true is returned, then B of ij is set to 1. So from here, what can I say? That the graph, in the graph B, or the matrix B that is representing the graph, if I see that there is an edge between two nodes, what does it mean? That those two students are either from the same city or from the same gender or both. Can I say that?
Ma'am,
Yes,
can you
ma'am.
repeat line 12? What's to present?
Line 12 will execute when the if condition is correct. That is, I and J are distinct students, and is related procedure for AI and AJ returns true. Is related will return true when they are either from same city, town, or have the same gender, or both. So if I see that is related is returning true and I and J are different, then B of ij in the matrix will be set to 1. So in adjacency matrix, if B of ij entry is 1, that means there is an edge from node I to node J. Here I and J are distinct students. So what can I say about the students in the graph? That there is an edge between two students if they are from the same city, or they are having the same gender, or both.
Yes, ma'am.
Yes, ma'am.
Correct.
Ma'am,
So now
ma'am,
yeah.
in step 8, when we create a matrix, ma'am, are the initial values assigned as 0?
Yeah, when you create matrix, this is the create matrix procedure, no? So this is how you create a matrix. Always when you create a new matrix, all values are 0. Then you
Okay.
assign 1.
Okay, ma'am. Okay, ma'am.
So we now understand what is B matrix representing. Now see the questions. There is an edge between students I and J with I not equal to J if and only if they are from same city, town, they have same gender, they are from same city, town, and have same gender, they are from same city, town, or have the same gender. So which one is closest in
Or
meaning?
have the same gender.
Last
Or
one.
have the same gender. Although this will also give true if both are true, right? Because or statement includes that both condition also. But since it specifies the or, so you just say or, because other three options are clearly wrong. So this is the correct one. Which of the following are true? Last of A01 represent gender of the student having sequence number 01. Is that correct? For every student, what is the first? City, town, last is gender. 01 is a sequence number. So last of A01 is the list, right? A01 represents the list of city, town, and gender for that student. So last of A01 is the gender.
Yes, ma'am.
Option A is correct.
Yes, ma'am.
Ma'am, for this, we don't
List of
have to draw a matrix or not?
No, this question you can solve without, but obviously you have to solve the entire code only before doing both the questions. So rest of A01 means you take out the first element, that is the city town. Represents gender of the student having sequence number 01. Is this correct? Rest of A01. Yes, no.
Yes, ma'am. It is correct.
Is everyone saying it's correct? It's not correct. Why? Last is such an operator which takes out the last element. So that's your gender. But when you do rest of A01, this is still in the form of a list. List containing gender. It is not the gender itself. So it doesn't represent the gender. It represents a list containing gender of the student having sequence 01. Two are different things.
Okay,
Right?
ma'am.
So this is wrong. C is saying in a graph, all students in a given clique are from same city town. So let's say there are 3 students like this, sequence number 1, sequence number 2, sequence number 3. They are all in a clique.
Yes, ma'am, true.
Is it true? Can it happen like this, that this is a female from Bangalore, this is a male from Bangalore,
No, ma'am. False.
this is a female from
No,
or
ma'am,
let's
it's a over
say,
condition.
yeah, it's an OR condition, right? That
No,
means
no,
it
that
can
means
happen like this, that this is a female from,
City is
let's say,
different, but
Mumbai.
gender is same.
Yeah, anything can happen, right? So this is a valid click. But here for nodes 2 and 3, city is not same, right? But it is still a valid click. No, this is wrong. Wait, this should be all female. Now this is correct. So the question is saying that if all the students are in a clique, they're from same city town. So they're also in a clique, but they're not from same city town. They're in a clique because they have the same gender, female. That's why there is an edge between every pair.
Ma'am, when you click, we have to say both the conditions should be
No,
satisfied.
no, no. To draw the edge, what is your condition? Either city town should be same or gender should be same. Both don't need to be same. There is an odd statement.
But ma'am, if that is the case, for above question 15, options A and B are also correct, isn't it? Because they have the same gender or they're from the same city and it's our condition.
No. See, if there is an edge, it is saying this is a sufficient condition, but it is not necessary. If and only if means necessary and sufficient. So if they
Oh,
are
I
from
see.
same city town,
Got it.
right? It doesn't always have to be same city town. It can be gender also. That's why. Okay, so option C is also wrong. D is saying if B of xy is 1 and B of yz is 1, that means there is an edge from student x to y, there is an edge from student y to z. Then they're saying there has to be an edge from student x to z. But that is not mandatory, right?
Yes,
X
ma'am.
and y and z might be connected due to different things. Let's say x and y are connected
Ma'am, one
because
can be
both are
connected for
female.
city and the other for the gender.
Correct. So these two might be connected because of gender. One is from Mumbai, one is from Bangalore. But again, there is a male student Z from Bangalore. So again, X, Y are connected, Y, Z are connected, but there is nothing in common between X and Z, right? So third option is also wrong. Clear?
How third? I don't understand third.
Third, no. Fourth option is wrong. Which one you don't understand? Option C.
Third option, yes.
It is saying in a graph, all students in a given clique have to be from the same city town. But that is not true. This is also a valid clique. But are they from same city town? They are all females. That's what is the common condition between them. 1 and 2 are female, 2 and 3 are female, 3 and 1 are female.
Okay,
So
ma'am.
edges are present.
Ma'am, if there
But they
is
can be
written
from
is-
different cities.
If the written is same city, town, and gender, then it is true, no?
Same city, town, and gender.
If they are
No,
talking
and
gender of
condition you cannot say.
or
All
or
students in a given clique must be from either same city town or from same gender or something. Okay, any one of these two might be,
then
must
this
have to
condition
be
is
true.
true, no?
Yeah. Okay. Now this is an important question. See, M is an adjacency matrix of a graph G given below. Okay, Mij is 1 if there is an edge from I to J, otherwise 0. List V represents the list of vertices. List V represents list of vertices of the graph G. How many vertices are there?
6.
6 vertices. So you have to answer these two questions based on this graph. So the procedure is running on the adjacency matrix M. I hope all of you can imagine the adjacency matrix, that where the edges will be, which entries will be 1, right?
Yes, ma'am.
These are
Yes, ma'am.
directed, remember. So if there is an edge from 3 to 0, so row 3 column 0, that entry is 1, but row 0 column 3 is not 1, correct? So temporary matrix is assigned. That means I'm creating a copy of the actual adjacency matrix so that I don't make any changes in the actual adjacency matrix. So you create a copy for each I in list V, that is list of vertices. So you pick one vertex I, one vertex J, one vertex K, 3 distinct vertices. See, these are all nested for each block. What am I checking? If M of Ij is equal to 1 and M of Jk is equal to 1. What does this statement mean? This if statement, there is an edge between I and J and an edge between J and K. Correct?
Yes, ma'am.
If both of these are true, then you come into the nested for each, where I'm checking for every L in list V. If M of K and L is equal to 1, that is, there is an edge between K and L. There is an edge between I and J, there is an edge between J and K, there is an edge between K and L. Then temporary matrix, that is the adjacency matrix copy that we created, we change the IL entry to 1. So from here, what can I say? That if there is an edge from I to J, if there is an edge from J to K, and if there is an edge from K to L, then we are saying there will be an edge from I to L. Is this similar to this or not?
Yes, ma'am.
And after doing this for every such IJKL group, you return the new updated temp matrix. So what will the values of P and Q be at the end of execution of the given code below? Now you have to do this on the actual graph. See, in new matrix is a variable where I'm running this update matrix procedure. Okay, the update matrix will change the temporary matrix in this way and return it, that we just discussed. Now in this new temporary matrix that has been returned, we are checking what is new matrix 2,5 entry. Is it 0 or 1? So check. Basically, I'm saying that if there is exactly a 3 length path between I and L, then I am saying that I to L, I am adding a direct edge. So 2, 5. See, if there is a 3 length path between 2 and 5, 2 to 1, this is your I, this is your J. I to J, there is a direct path. J to K, there is a direct path. K to L, there is a direct path. So will there be a direct path from I to L added in the new matrix?
No, ma'am.
L to
Why
I.
not?
L to I is
Oh.
I to L is not.
That L to I edge is already present. But when you're updating the matrix, updating the this adjacency matrix, what is the condition I told you? That if Mij is 1, Mjk is 1, and Mkl is 1, then we are setting IL to 1 as well.
No,
That's
ma'am,
what is
this
happening
condition is
here.
not satisfying.
Why is it not satisfying? For new
Ma'am, we are
matrix 2,5.
updating the graph, no?
Yes, not the graph, the matrix.
The matrix. Then it's okay.
It is fine. So that's
Yes,
what I'm
ma'am.
asking, that what will be P and what will be Q if I am running new matrix 2,5 for second row, that is for second node and fifth node.
P0.
P is 0 or 1?
Ma'am, one.
One, ma'am.
Why will it be 0? See, just think of this 2 as your I. We have to, our job is that we can say that I to L, that is new matrix IL 2, 5 will be 1 when there is a 3 length path from I to L. So is there one? See, I to J, that is 2 to 1, J to K, that is 1 to 4, and K to L, that is 4 to 5. There is a 3 length path present. That means this code is being satisfied. This condition is also true. This condition is also true. Then in temporary matrix, I is what? 2, L is what? 5. 2, 5 is set to 1 or not?
Yes, ma'am.
So P value will be 1 or 0.
1.
Similarly, check for Q, 0 to 5. So we have to find a 3 length path between 0 and 5.
Ma'am, I have a question.
Yeah.
Ma'am, when we say I to L, that means we are going from I to L. That means the arrow is directed towards L, right?
This. If this is I, this is L. So 2 to 5. This new edge is now added in the matrix. Got it?
Now, can you take by making a matrix so it's more easier to understand?
All entries are 0 initially. Now just by looking at this graph, tell me which entries are 1. 0 to 2, there is an edge. So 0 row, column 2. This is 1. 3 to 0, there is an edge. Row 3, column 0. This is 1. 2 to 3, there is an edge. Row 2, column 3. This is 1. 2 to 1.
2 to 1.
Row 2, column 1. 1 to 4. Row 1, column 4.
4 to 5.
4 to 5. Row 4, column 5.
5
5 to
to
2.
2.
Row 5, column 2.
2 to
Anything I
3.
missed? No.
2 to
2 to 3 I've already placed. This one. So all of these are done. So now I am checking what? That is there a 3 length path from I2 to L5? Your I is 2, your L is 5. So check that from 2, where can I go? From 2, I can go to 1. Right? So this is my J. From 1, where can I go? From 1, I can go to only 4.
4.
This is your K. From 4, where can you go? Only
L.
one place.
5.
5. This is your L. So these are the 3 conditions I'm checking in the code, right? That I to J, J to K. Both of these are 1. And K to L also there is a path. So all 3 are correct. That means the IL entry is now set to 1. Temp mat IL is set to 1. What is IL? I is 2. L is 5. So 2,
Yes.
5. This one will be 1 now.
Yes, ma'am.
That's what is happening. So similarly, you now tell me if I is 0 and L is 5, then Q value will be what? From 0 to 5,
0.
is there
0,
such a path?
ma'am. 0.
So there is no such path. There is no 3 length path. There is a 4 length path.
4 length.
But that is not valid, right? We want I to J, J to K, K to L. That is not happening here. So Q will remain 0.
Now here we're
P
doing
is 1.
DFC, na? DFS.
DFS.
By DFS, we are checking, na?
This is not BFS. This is DFS.
Yes, ma'am, DFS.
Depth first. No, because we are going from 0 to 2, then 2 to 1. We are not exploring the neighbors. If I start from 2, I'm going 2 to 1, 1 to 4, 4 to 5. I'm not exploring 2 to 1, then 2 to 3. In BFS, you first explore all the neighbors. Breadth first search. In DFS, you go depth wise. So this is DFS.
Okay, ma'am.
So option B here is correct. P1, Q0. This is clear for everybody?
Yes, ma'am.
Okay. Question 18C. Same code, only minor changes there. That now you're checking I to J, there is an edge. J to K, there is an edge. And you're checking K to I, there is an edge. Then count is implemented. So what will be the value of count? So let's find how many such pairs I can find of I, J, K where these conditions will hold true. That is, so it's like this. Node I, node J, node K. Okay, so I to J, there is an edge. J to K, there is an edge.
Ma'am, will it
K
form a
to I.
click?
This is not a click. Is I connected to K? Can you go from I to K
No, ma'am.
directly? No. So this is directed graph. So clicks forming won't be that easy, right? In undirected graph, if it was, then it's a click.
Click only form in indirected graph.
We usually show you undirected clicks only, okay? Not to make it too complicated. So in this code, now you tell me how many such pairs can I find? So first, let's check.
From 0 to 2,
From
2 to
0
3.
to 2. So I to J, J to K.
Yeah.
And then K to I, there is also a path. So
Yes,
this
ma'am.
is one valid cycle. So count will be incremented once for this. Any others can we find like this?
No,
No, ma'am.
No, ma'am.
This type of a 3-node cycle?
No,
No.
ma'am.
There is only one. So count will be what?
1.
One only. Wait, they're saying 3. Something we are missing. Let's check.
Yes, it would be 3 because
Oh,
0,
okay,
2,
because
3,
each
2,
of
3,
the
3.
correct. Because we are checking for all IJK combinations, right? So once the I is 0, once the J will once the I will be 2, once the I will be 3. Did you
Also,
understand why it's 3?
Yes,
the
ma'am.
ones that are having 4 nodes connections, we are updating the node to 1 in the code. So there's an update happening too.
Oh, 1 second. This code you're saying?
Oh yeah,
There is no
it's
update in this one. Okay. So this is
right.
just checking condition and incrementing count. So it is finding this 3-node cycles. There is only
That's
one
right.
3-node cycle, but the I value will keep changing. Once it will take node 0 as I, once node 2 as I, once node 3 as I. So totally this same click will be counted, the cycle will be counted 3 times. That's why the
Correct.
count is 3. Okay. Now this is the last one. This is also very simple. See, M is again adjacency matrix of this given graph, and we have to execute the do something procedure. So do something is doing what? It is taking the adjacency matrix M and some vertex Q. Okay, I think Q is a vertex only. So some vertex Q and the adjacency matrix M are taken as parameters. Count is set to 0 for each I in rows of M. So rows of M and columns of M contain equal number of elements, correct? All of the nodes. So we are finding all possible combinations in this of I and K. So see this. For each I in rows of M, for each I will go through all possible Ks. Right? That is all other nodes. I included. If M of IQ is 1, that is there is an edge from I to Q. I is a node, Q is a node. There is an edge from I to Q. This is also directed graph. And Q to K, there is an edge. If both of these are correct, then count is incremented by 1. That means Q is the parameter that remains fixed. So we are finding how many such pairs of IK I can found for a particular Q value, right? That means this will be given to you. See, in the question that they have asked, they are asking what will be the value of B when I execute do something M1. So 1 is your Q, 1 remains fixed. So if Q is 1, how many such IK pairs can you find where this is correct? That I to 1 there is an edge and 1 to K there is an edge. So let's check if this is my Q. Can I say 0 is a valid I?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
And 2
2
is a
is
valid
K.
K.
Yeah.
So
Yes.
0 to 1, 1 to 2. So that means count is incremented by 1. Any others?
No, ma'am.
No.
Because 1 only has one incoming edge, right? One
Yes.
incoming, one outgoing. So at most once the count will be incremented. So for B, the answer is 1. Now if I take the vertex 5, which is the next question. For 5C, are there any incoming edges? Yes. 2 incoming edges. But are there any outgoing edges?
No,
No,
ma'am.
ma'am.
No, ma'am.
No,
That
ma'am.
means 0 number of such K values are possible. So count
Yes.
will be
Ma'am,
incremented 0 number of times.
No, it will be 0.
ma'am, 0 has a outgoing, right? 3.
I'm checking for node 5 now. Now Q is 5.
Okay.
Okay. So Q has 2 incoming edges but 0 outgoing edges. So no IK pairs I will be able to find. Right. So for 5, B value will be what? Or count will be what?
0.
0 only.
0.
That's it. So this is the type of graph questions we'll get. So this is end of all the questions for this paper. I hope for everyone all the questions are clear, right?
Yes, ma'am.
Yes,
This
ma'am.
was a good level paper. The end term will be of this level
Yeah,
only.
yeah, ma'am. Actually, I have some doubt. Can you please go up?
Which one?
First graph question.
Okay.
The
First graph that is
question
this one.
where
the
there
click
was option.
question.
No, where there was an option on raised A0 something was there. The option was there.
Let me check. This one.
Yeah, this yes, sir.
Okay.
Could you
This
explain the
option B.
second? I couldn't
Yeah.
get it.
Why this is wrong is, see, I said that for a student, this is the way in which the value is given in the dictionary, right? The sequence number is the key. This is the value. City, town, comma, gender in a list. So if I take rest of A01, where 01 is a sequence number. So rest of a list means which element is taken out? First element.
Yes.
So city, town is removed. What is remaining? Gender
Gender.
inside a list. But this does not represent the gender of the student having sequence number 01. It represents a list containing the gender. Okay. If I said first of rest of 01, or if I said last of 01, that is the gender. But list containing gender and gender itself are different things.
Okay, first and last gives a sort of
Gives the actual element.
actual
Okay.
value
They
of
fetch
that.
the element. Yeah.
Okay. And rest gives a
Rest
list.
gives the list. Yeah. So here, if you want that, so you can write that first of rest of A01. This will give you the gender. Or even last of rest of A01. That will also give you the gender, because there is only one element present once you take out city, town. Okay. But only rest is just going to give a list.
One more doubt I have.
Yeah.
Okay, so there are some questions that some cards are picked up and then moved to some other table, then table 2, table 3. I think the questions were discussed earlier. I couldn't have this one.
No,
not this
I don't
one.
think this one. There is another one. Wait.
I think the shopping bill or some words
Yeah,
it does it.
shopping bills.
Yeah, this one.
This
So
one, yeah.
I get confused around this thing, but how table some cards are picking from table 1, then they're moving to.
1, 2,
Could you
3
explain
are
this?
different tables. Yeah. So
Okay.
in the beginning, all cards are there in table 1. Okay. Now what you're saying here is, see, every time I read a card, you read the first row. That is, you read the first card and you move it to table 2. That means this card has been read. Now, based on this card, I'm doing the rest of the comparisons in the inner while loop. Okay. So that card is not going to be repeated in the future. In the inner while loop, wherever I find a match with the customer name for the current card, I remove those cards also, because these are all cards from the same customer. So these cards should not be compared again in the future. So they are all moved to table 2. Now the cards which do not match, which are from different customers, they are moved to table 3, and later on table 3 is revived, because at the end of execution of this inner while loop, all the cards are going to be moved to table 2 and table 3. Table 2 cards are the cards that we don't want to repeat again. Table 3 cards are the ones that we need to bring back, because those are different customers, the ones that we haven't compared yet. Okay. So cards that you don't want, you place in table 2 in this particular format. So table 2 cards, we don't want to compare again in the future, because table 2 is not being revived anywhere. Table 3 cards are the ones that we bring back every time. So in the next iteration, when you check for a different customer, again, some new cards will be added to table 2. At the end, again, table 3 cards will be revived. So like this, at some point, all the cards will move to table 2 when table 3 is empty.
Okay,
That
so
is
what I
it
get,
for
I'll read it what I understood. So basically, we are picking one card and we are comparing from the remaining cards. And if the condition is satisfied, then we are moving to table 2. Otherwise, if all the we have checked with the remaining
It completely
remaining
depends
cards.
on the context. See, in
Yeah,
this
yeah,
particular
yeah.
question, this is the context. Yeah, you
Yeah,
have
yeah.
understood correctly. In this question, this is the context that if I don't want to repeat a card, I'm sending it to table 2.
Okay. Okay, so in the end term, will the number of questions be same like 20?
Yeah, 20
Around
questions.
20?
Yes. Yeah.
And the pattern will be like this
Like
or
this
no?
only. Like this.
Okay, thank you.
So from graph, there will be good number of questions. So don't leave graph or matrix that part. You should do weeks 9 to 11 good in a good solid manner, because from there definite questions will come.
Ma'am,
Yeah.
where can we get this PDF?
Yes, you cannot get this. I have, if you want, I can post it in the
Yes, please, ma'am.
chat
Yes,
box.
Because I couldn't join the session and I want to solve these questions. So if it will be helpful.
Yeah, I'll give you, but do you want the annotated one, or should I discard these changes and give you the fresh PDF?
Yeah, give me the fresh PDF so that I solve
Yeah.
myself.
Okay.
The solved ones as well as the first PDF, both if you can send, right, we can refer both. And when we solve, then we can see whether our answers are correct too, ma'am.
1 second. Let me check if I can do that.
And one more thing, ma'am, like what is the duration of the exam, ma'am, for the CT alone?
1.5 hours, I think.
1.5 hours. Okay.
Okay, let me first share this. Yeah, 20 questions will be there.
Ma'am, can we get the week 9 to 12 PDF as well?
9 to 12. I didn't discuss 9 to 12. I don't have it. I think tomorrow there is one more session. There you can ask the instructor who took 9 to 12. They can give you.
This is the end term, right, ma'am? Like the full set of questions, right?
Yeah, this is the end-term paper from September 24th term.
Okay.
Ma'am, this session is recorded, right?
Yeah, it is recorded.
Okay.
And was there any summary session of 9 to 12?
There was. I think the last session only was the summary session. Just a second, let me paste that.
Ma'am, anyway, we can get a link of yesterday's session.
In YouTube, you can find, no? 24 September. This is the end-term paper.
Ma'am,
Yeah.
ma'am, in our quiz 3, this type of questions will come, isn't it?
Yeah, this is your end term. So this is the pattern of questions in end term. The PIQ we solved is from September 24th term.
Okay.
Okay, I've pasted it. You can check if you got it on the
Okay.
chat. All right, yeah. Thank you, everyone. Thanks for joining. All the best for your exams.
Thank you so much, ma'am.
Okay, you can leave.
Ma'am, recorded
Thank you,
lecture will be uploaded, right, ma'am?
Yeah, it's on YouTube.
No, today's, ma'am?
Yeah, today's one also will be on YouTube only.
Okay.
Thank you.
Mm-hmm.
Hello.
So